Hello, this is an informative video regarding Project CircleWaste, scaling up eWaste circular economy in ADRION region. We are going to talk about Module 1, what is eWaste and why does it matter. This is a content prepared by PP7, Center for Education Development, Albania. Here, introduction is regarding electronic waste, eWaste, also known as waste electrical and electronic equipment, is one of the fastest growing waste streams globally. The increasing use of electronic devices combined with shorter product life cycles and rapid technological innovation has significantly increased the generation of electronic waste in recent decades. Data collection plays a fundamental role in understanding how electronic waste flows through the economy. By collecting data from producers, municipalities, recycling companies, and other stakeholders, researchers, and policymakers can evaluate the performance of waste management systems and identify areas where improvements are needed. Within the CircleWaste project, collecting reliable data on electronic waste is an important step in supporting the development of sustainable solutions and strengthening circular economy practices across the Adriatic Ionian region. This module provides an overview of how electronic waste data is collected, who is responsible for collecting it, and what methods are commonly used to gather information about the e-waste sector. But firstly, we need to understand electronic waste. E-waste is formally referred to in many regulatory frameworks as waste electrical and electronic equipment. The management of WEEE has become an important environmental issue due to the rapid growth of electronic device consumption worldwide. Electronic waste includes a wide range of products used in everyday life and across different sectors of the economy. Examples of the electronic waste include information and communication technology equipment, desktop computers, laptops and notebooks, servers and data storage equipments, printers and scanners, mobile phones and smartphones, tablets and other portable digital devices. Regarding the consumer electronics, are televisions and monitors, audio systems and speakers, digital cameras and video equipments, gaming consoles, DVD players, and entertainment devices. Regarding large household appliances are refrigerators and freezers, washing machines and dryers, dishwashers, air conditioners, and electric stoves and ovens. Regarding small household appliances are vacuum cleaners, microwaves, coffee machines, electric kettles, hair dryers, and grooming devices. While talking about lighting equipments are fluorescent lamps, LED lighting systems, and lighting fixtures and electrical components. Regarding professional and industrial equipment is electronic medical devices, monitoring equipment, electronic tools used in workshops or construction, laboratory equipment. Materials contained in electronic waste. Electronic devices are composed of a complex combination of materials. Many of these materials are valuable and can be recovered through recycling processes. Common materials found in electronic waste include metals such as copper, aluminium, iron, and steel, precious metals such as gold, silver, platinum, and palladium, plastic used in device casing and components, glass used in screens and displays, rare earth elements used in electronic circuits and advanced technologies. Hazardous substances in electronic waste. Although electronic devices contain valuable materials, they may also have to include hazardous substances that can pose risks to human health and the environment if not properly managed. Examples of these potential substances found in electronic waste include lead, commonly found in solder and electronic components, mercury, used in certain lighting systems and switches, cadmium, used in batteries and some electronic components, brominated flame retardants used in plastic to reduce fire risk, chlorinated compounds used in insulation materials. Environmental and economic importance of e-waste management. Effective management of electronic waste is important not only for environmental protection but also for economic sustainability. From an environmental perspective, responsible e-waste management helps to prevent the release of hazardous substances into the environment, reduce pollution of soil, water, and air, conserve natural resources by recovering valuable materials, reduce the environmental impacts associated with mining and manufacturing. From an economic perspective, electronic waste represents a significant source of secondary raw materials. The recovery of valuable metals and components from discarded devices can support the development of recycling industries and create economic opportunities. Key economic benefits include development of recycling and material recovery industries, job creation in waste management and circular economy sectors, reduced dependence on imported raw materials, and innovation in recycling technologies and product design. Importance of monitoring electronic waste is regarding monitoring electronic waste helps policymakers and researchers understand how much electronic waste is generated each year, which types of electronic products are more frequently discarded, how effectively waste collection system operates, how much electronic waste is recycled or reused, what gaps exist in recycling infrastructure. Collecting reliable data on electronic waste is therefore essential for developing effective waste management policies and supporting the transition toward a more sustainable and circular economy. Why data collection is important? Reliable data is essential for understanding how electronic waste is generated, collected, transported, reused, and processed within the waste management system. Without accurate and consistent data, policymakers, researchers, and industry stakeholders cannot fully assess the scale of the electronic waste problem or design effective strategies to address it. Understanding the scale of the e-waste problem. Data collection helps determine the quantity of electrical and electronic equipment placed on the market, the types of electronic products most commonly used by consumers, the amount of electronic waste generated annually, the growth rate of electronic waste generation over time, the sectors responsible for generating the largest quantities of e-waste. Monitoring collection and recycling systems. Key indicators that can be monitored include the amount of electronic waste collected through official collection points, the volume of waste transported to recycling facilities, the recycling and material recovery rates achieved by processing facilities, the quantity of waste diverted from landfills, and the proportion of the e-waste that is reused, refurbished, or recycled. To identify infrastructure gaps, stakeholders can identify through data analysis regions with limited access to e-waste collection points, areas where recycling infrastructure is lacking, logistical challenges related to transporting electronic waste, differences in waste management performance between urban and rural areas, opportunities for expanding collection networks or recycling facilities. Supporting circular economy development, information collected through surveys and reporting system can support the development of recycling industries, the promotion of reuse and refurbishment activities, the recovery of valuable raw materials from discarded electronics, the creation of secondary raw material markets, the development of innovative recycling technologies, supporting research and innovation. Research supported by reliable data can contribute to improving recycling technologies, designing more sustainable electronic products, developing new methods for recovering valuable materials, promoting eco-design and sustainable product life cycles. Innovation in the e-waste sector plays an important role in supporting transition toward the circular economy. Stakeholders involved in e-waste data collection. Each stakeholder contributes specific types of information that help build a comprehensive understanding of how electronic waste flows through the economy. By combining data from these different actors, policymakers, researchers, and project partners can develop a more complete picture of the e-waste ecosystem and identify opportunities for improving waste management systems. Some stakeholders are producers and importers. Typical data collected from producers and importers may include the quantity of electrical and electronic equipment placed on the market, the categories of electronic products sold or distributed, product life cycle information, the weight or volume of equipment introduced into the market, information related to product design and materials. Other stakeholders are municipalities, which collect important data related to the collection of electronic waste within their territories. Examples of data collected by municipalities include the quantity of electronic waste collected through municipal collection points, number, location of designated e-waste collection facilities, the frequency of collection services for electronic waste, participation rates of households and business in recycling programs, operational costs associated with waste collection services. Another stakeholder are recycling companies, which they provide important operational data that helps measure the performance of recycling systems. Examples of data collected from recycling facilities include the total quantity of electronic waste received by processing, the types of electronic equipment processed, the quantity of materials recovered during recycling processes, the recycling efficiency rates for different materials, and the disposal methods used for hazardous components. Reuse and refurbishment organizations play an important role in extending the life cycle of electronic products. Organizations involved in reuse and refurbishment may collect data related to the number of electronic devices repaired or refurbished, the categories of devices suitable for use, the average lifespan of refurbished equipment, the number of devices redistributed to new users, the environmental benefits of reuse activities. Types of e-waste data collected. In order to effectively manage electronic waste and support circular economy practices, it is necessary to collect a wide range of data related to the production, consumption, collection, treatment, and recycling of electronic and electric equipment. Different types of data provide insights into how electronic waste flows through the economy and help stakeholders evaluate the effectiveness of e-waste management systems. Collecting comprehensive data allows policymakers, researchers, and industry stakeholders to monitor the performance of e-waste management system, identify operational challenges, and develop strategies for improving recycling and reuse activities. The types of electronic waste data typically collected can be grouped into several key categories, which are data on electrical and electronic equipment placed in the market, which may include total weight of electrical and electronic equipment sold annually, number of units sold by product category, types of electronic device distributed to the market, distribution of products across consumer, business, and industrial sectors, expected lifespan of different categories of electronic equipment. Then data on electronic waste generation. Understanding waste generation patterns helps policymakers determine the scale of the e-waste problem and identify trends related to electronic device consumption. Examples of data collected in this category include estimated volume of electronic waste generated annually, types of electronic type of electronic devices most frequently disordered, distribution of waste generation between household and businesses, trends in electronic waste generation over time, seasonal or regional variation in waste generation. Data on waste collection systems. Efficient collection systems are essential for ensuring that electronic waste is properly managed and diverted from landfills. That data related to waste collection may include quantity of electronic waste collected through official collection points, number and location of collection centers, frequency of waste collection services, participation rates of households in electronic waste collection programs, volume of waste collected through special collection events. Data on recycling and treatment process. Recycling companies collect detailed operational data that provides insights into how electronic waste is processed. Examples of recycling data include total quantity of electronic waste received for treatment, types of devices processed by recycling facilities, quantity of materials recovered through recycling, recovery rates for metals, plastics, and other materials, quantity of hazardous substances safely removed or treated. Data collected through surveys and stakeholder questionnaires. In many research projects and market assessments, data is also collected directly from stakeholders through surveys and questionnaires. These tools allow researchers to gather information that may not be available through administrative databases of official reporting systems. Survey-based data may include information about the role of organizations within the e-waste value chain, operational challenges faced by recycling companies, barriers affecting the development of reuse markets, regulatory or administrative obstacles, stakeholder perspectives on policy improvements, data on environmental and economic impact. In addition to operational data related to waste management, some studies also collect information related to the environmental and economic impacts of electronic waste management systems. Examples of this type of data include greenhouse gas emissions associated with electronic waste processing, environmental benefits achieved through recycling activities, economic value of recovered materials, job creation in recycling and reuse industries, investment levels in recycling infrastructure and technologies. Methods used to collect e-waste data. Collecting reliable and comprehensive data on electronic waste requires the use of different data collection methods. Because the e-waste ecosystem involves multiple stakeholders and complex processes, no single data collection approach can provide a complete picture of the sector. Instead, several complementary methods are typically used to gather information from different sources. These methods allow researchers, policymakers, and waste management authorities to monitor the generation, collection, treatment, and recycling of electronic waste. Combining different data sources improves the accuracy and reliability of the information collected. The most commonly used methods for collecting e-waste data include reporting system, administrative database, stakeholder surveys, field assessments, and digital monitoring tools. Reporting system and regulatory reporting. One of the primary sources of electronic waste data in regulatory reporting systems. In many countries, companies and waste management operators are required by law to report information related to electronic products and waste management activities. Examples of data reported through regulatory systems include quantities of electrical and electronic equipment placed on the market, quantities of electronic waste collected and processed, recycling and recovery rates achieved by treatment facilities, compliance with environmental standards, operational information related to waste management activities. National Waste Management Database. Many countries maintain centralized database that collect and organize information related to waste generation and treatment. These databases serve as an important source of statistical information for policymakers, researchers, and environmental agencies. National Waste Management Database typically include information such as annual quantities of electronic waste generated, recycling rates for different categories of electronic equipment, number of authorized recycling facilities, trends in electronic waste generation over time, field assessments and on-site data collection. Another method used to collect e-waste involves field assessments, and on-site visits to waste management facilities. During these assessments, researchers or regulatory authorities gather information directly from operational environments. Field assessments may involve visiting recycling facilities to observe processing operations, inspecting municipal waste collection centers, monitoring waste transportation systems, interviewing facility managers or technical staff, verifying reported data through direct observation. eWaste data collection process, step-by-step approach. So basically the first step is to clearly define the purpose of the data collection activity, establishing clear objectives help determine what type of information needs to be collected and how it will be used. Step 2, once the objectives are defined, the next step is to identify the stakeholders who can provide relevant data. These stakeholders may include producers, municipalities, recycling companies, reuse organizations, and government institutions. After identifying stakeholders, step 3 is appropriate methods must be selected to collect the required data. These methods may include surveys, regulatory reporting systems, national databases, or field assessments. In step 4, data collection tools such as questionnaires, reporting templates, or digital forms are developed to gather information from stakeholders. These tools must be clear, structured, and aligned within the objective of the data collection process. In step 5, in this stage, data collection tools are distributed to stakeholders and responses are gathered. This may involve sending online surveys, conducting interviews, or collecting reports from organizations involved in the e-waste sector. In the step 6, once data has been collected, it must be reviewed to ensure its accuracy and completeness. Data verification helps identify missing information, inconsistencies, or errors that may affect the reliability of the analysis. In step 7, after validation, the collected data is analyzed to identify trends, patterns, and key insights related to electronic waste management. This analysis helps stakeholders better understand the performance and challenges of the e-waste ecosystem. In step 8, using the data to support decision making, the final step involves using the analyzed data to support strategic planning and policy development. The results can inform improvements in e-waste management systems, recycling infrastructure, and circular economy initiatives. Digital tools for data collection. Digital tools are particularly useful in projects that involve stakeholders located in different regions or countries, as they allow surveys to be distributed quickly and assessed remotely by respondents. Participants can complete questionnaires using computers, tablets, or mobile devices, making the data collection process more flexible and accessible. Online survey platforms provide several advantages for data collection, including easy creation of structured questionnaires, distribution of surveys through links or email invitation, automatic storage of responses, real-time monitoring, simple export of results to spreadsheets for analysis. These features significantly reduce the administrative workload associated with collecting and processing survey responses. Several digital tools are widely used for questionnaire design and data collection, such as Google Form, Microsoft Form, SurveyMonkey, and Lime Survey. These tools enable researchers to distribute surveys through shareable links, automatically collect responses, and export results to spreadsheets or statistical software for further analysis. By using digital tools, project teams can improve the efficiency of the data collection process while ensuring that information is organized in a format that supports accurate analysis and reporting. Conclusions. Collecting reliable data is a fundamental step in improving electronic waste management system and supporting transition toward the circular economy. Accurate and well-organized data helps stakeholders better understand how electronic waste is generated, collected, treated, and recycled across different regions. By gathering information from the various actors involved in the e-waste value chain, researchers and policymakers can gain valuable insights into the functioning of the sector and identify areas where improvement are needed. Several methods are used to collect the information, including regulatory reporting systems, national statistical databases, stakeholder surveys, and digital monitoring tools. These approaches help ensure that data is collected in a structured and consistent manner, enabling reliable analysis and comparison across regions. Within the CircleWaste project, questionnaires and digital data collection tools have played an important role in assessing the e-waste business market and identifying challenges faced by stakeholders involved in electronic waste management. The information gathered through these activities contributes to a better understanding of market dynamics, recycling capacities, and operational barriers within the sector. Furthermore, understanding how electronic waste data is collected strengthens cooperation between stakeholders and promotes transparency in waste management systems. Reliable data allows project partners, policymakers, and business to design more effective strategies for improving recycling infrastructure, supporting reuse activities, and encouraging responsible waste management. Ultimately, systematic data collection supports the development of more sustainable and circular approaches to electronic waste management, helping societies reduce environmental impacts while recovering valuable resources from discarded electronic equipment. Thank you for watching. This content was prepared by Center for Education and Development Albania.